Good afternoon, students. Let us continue our discussion on engineering curves. The next question says that draw a cycloid for a circular plane 70 mm in diameter, which rolls on a horizontal surface for one complete revolution. Assume that the point P is at the top of the circular plane. So if you observe the question carefully, the only difference between the previous question and this question is here the position of point P is given at the top, whereas in previous question we have taken the point P at the bottom of the circle. So let us start making the cycloid for the given data. So first we need to draw a circle. So as per the question, it is given that we need to draw a circle of diameter 70 mm, that is radius 35. So I will measure 35 in compass, 3.5, and then we will make a circle. Now, next step is to divide the circle into 8 equal parts. So 4 parts can be done by using a scale. Just keep at the center and draw a line. Similarly, a vertical line. And then as we are dividing into 8 parts, we have to mark 45 degrees. So 45 is here, marking this side. And similarly, 45 from this side, it comes somewhere here. And this is the point. Then by using the scale, we need to draw a line. Then similarly from this side. So in the question, it was given that we have to draw a cycloid for one complete revolution. So one complete revolution means the circumference of the circle. So if you calculate by using the formula 2 pi r, it comes out to be as 219.8 mm. So we need to draw a line of 219.8 mm starting from the bottom. Then we need to divide this line into same number of equal parts as that we have drawn as we have divided the circle. So as we have divided the circle into 8 equal parts, this line, entire line will also be divided into 8 equal parts by using that parallel line concept. So what I will do is I will make a line around 30 degrees. It can be made at any angle. Any length. Then what you need to do is you mark some equidistance point. For example, if you are taking 1 centimeter, mark 1 centimeter 8 points. If you are taking 2 centimeter, mark 2 centimeter 8 points. Let us say I will mark at 2 centimeters. So I will just mark the things 1, then it will be going to 4, then 6, then 8, then it will be 10, then 12, 14, and finally 16. So this we have divided into 8 parts. Now what you need to do is you need to join this last point of the circumference line by means of a straight line. Then just make this scale parallel and draw the parallel lines from each of the points. So with this, we have divided this line also into 8 equal parts. Now we will give the numbering. Numbering is also important. How to give the numbers in the cycloid part. So in the question, it was given that point P is to be on the top of the circle. So if point P is on the top of circle, I will write P here. And if this is P, you have to give the next number as 1. So starting from P, it will be rolling in clockwise direction. So in clockwise direction, next number will be 1 here. So this is point 1, then point 2, point 3, point 4, point 5, and so on. 6, 7, and 8. So point P and 8 will be same. Similarly, we will give name here also. So this point will be 1, this point will be 2, this is 3, 4, 5, 6, 7, and 8. Now what we need to do is we need to draw vertical lines from all these points 1, 2, 3, 4, 5, 6, 7, 8, and all horizontal lines from points on the circle from the same numbers 1, 2, 3, 4, 5, 6, 7, 8. Also, I will name the center as C. Whatever I am making in yellow will be the lightest part, and whatever is there in black will be the dark part. Similarly, from all these points, we have to draw vertical lines. Now, wherever they are intersecting at the center line, we name that as centers as C1, C2, C3, and so on. So the projector from 1 is cutting the center line at this particular point, and this will be named as C1. Similarly, this point will be named as C2. This will be termed as C3, C7, and C8. Now comes the important part, the marking of arcs for the cycloid. So for that, I have given you the hint on in the previous class that when point P is moving towards downside, we will make a cut on the right hand side. And when P starts moving upwards, we will make a cut on the left hand side. So now the position of P is at the top, and if the circle is rolling in clockwise direction, point P direction will be coming towards downside. So as it is coming towards downside, we will make the cuts on the right hand side. So starting with the part, so first of all, we have to measure the radius, which was 3.5. Then keep it on center C1 and make an arc on the projector of 1 on right hand side. So this arc will be made here. Similarly, when I keep it on point C2, we have to cut an arc on projector from line 2. So line 2 projector is this one. We have to make an arc on this particular line again on the right hand side. So the cut will be here, this side. So it will be here like this. Then we will shift our center to C3. Again from point 3, it will be the arc will be cut on the projector of point 3, which is this one. This is projector of point 3. So this way it will be cut. Then we will shift to center 4 and cut on a line of C4, which is this one, the line at the bottom. And if your construction is perfect, this will exactly become a tangent. This line will become tangent to this curve. Now, till point 1, 2, 3, and 4, point P was traveling in the downward direction. Hence, we make a cut on the right hand side. Now, when P comes here at this particular position, point number 4, now it will try to go in the upward direction. And because it is moving in the upward direction, we will make a cut on the left hand side. So from point C5, we will make a cut on projector of 5, but now on the left hand side, not on the right hand side. So it will be somewhere here on the projector of 5 on left hand side. So the cut will be made here. This. Now shifting our center to C6 and make a cut on the projector of C6. That is this one, line 6. So it will be somewhere here. Then shifting our center to C7 and making a arc on the projector of 7, which is this one. Again, it will be on left hand side only. So it will be marked this particular way. And then finally shifting the center to 8 and making an arc on the projector of 8. And if your construction is perfect, again, this arc will perfectly be a tangent to this projector. Now we have to name these points as P1, P2, P3, P4, etc. So starting with the namings. So this was P1. And this is P2. And this is P3 and P8. Now we have to join these points by means of a smooth curve starting from point P, and the curve should pass from all these points P1, P2, P3, P4, P5, P6, P7, and P8. So this completes the cycloid part. Now now let us say if it is asked to draw a normal and tangent to the curve. So the procedure is, if it is asked in the question that draw normal and tangent to any point on the curve, then you select any point on the curve. So let us say I will be selecting this point on which I want to draw the tangent and normal. So from this point, you have to again take the same radius. So keeping the compass at this particular point from which you want to make the radius, from which you want to make a normal and tangent, make a arc on the center line. Then wherever this arc cuts on the center line, we have to draw one vertical line connecting the circumference line. Now this point where it cuts the circumference line has to be joined by the point on which we want to draw the normal and tangent. Like this. So this line which we have just now joined is nothing but the normal. And now we know that normal and tangent are always perpendicular to each other. So we'll just take our protractor, mark 90 degrees here. And then by means of a scale, join this. And this becomes the tangent, naming it as TT. That is tangent. And let us say this point on which we have drawn the tangent, let us say this point is M. You can name any the point as per your choice. I am keeping it as point M. So this completes the cycloid of a curve of a path traced by the point which is on the top of the circumference of the circle. So in question, normally it is also asked after tracing the locus, also name the curve. So we have to name the curve as cycloid. This will be giving you 1 marks, writing the name of the curve as cycloid. And then finally, we are remaining with the dimension part. We'll just give the dimensions, the important dimensions. So now this completes the problem in all respects. I hope you have understood the question. The only difference between the previous question and this question was the location of point P. In previous case, it was located at the bottom of the circle. Now it is starting from the top of the circle. Okay. Thank you.